Good afternoon, my name is Emily Brotherton, and today I'll be sharing with you some preliminary results from my research that investigates central mechanisms that contribute to muscle fatigue in people with multiple sclerosis. So multiple sclerosis, or MS, is an autoimmune neurodegenerative disease that attacks the myelin that surrounds the axons in the brain and the spinal cord. And this can interrupt pathways for motor function. Therefore, it's not surprising that fatigue is reported to be the most common symptom in this population. People with MS have been documented to demonstrate a reduction in force output during fatiguing contractions, suggested to be due to a reduction in neural drive from the motor cortex to the muscle. This study shown in the graph on the left measured voluntary activation as an index of neural drive by applying stimulations to the ulnar nerve during a sustained maximum voluntary contraction for 2 minutes. They found that in conjunction to a reduction in neural drive from the peripheral nerve in MS individuals, cortical activity measured through fMRI, as depicted in the figure on the right, was also reduced. This indicates that a reduction in voluntary activation via peripheral nerve stimulation during an MVC is associated with a reduction in cortical activity in people with MS. We developed a protocol to examine neural drive from the motor cortex to the muscle during a low-intensity elbow flexion task. So far, 9 MS and 10 controls have performed the protocol, with data collection ongoing. The protocol involves an elbow flexion task with TMS applied to the motor cortex and motor point stimulation applied at the biceps muscle. The experimental protocol is a 26-minute sustained elbow flexion at a low intensity of 15% of MVC. Throughout the low intensity contraction, MVCs were performed to examine the force generating capacity of the group, as well as superimposed twitches elicited by TMS and motor point stimulation. Following the low intensity contraction, the recovery period commenced, and once again, TMS and motor point stimulation were used to elicit superimposed twitches. The rate of perceived exertion was also measured throughout the exercise task in both groups. And these are the results to date. This graph represents the MVCs performed throughout the exercise task and in recovery. There was a main effect of group on MVC, with individuals with MS demonstrating a reduced MVC during the exercise task compared to controls. This indicates that the MS group were more fatigued than controls. Despite this, there were no differences in the rate of perceived exertion during the exercise task between groups. The graph on the right represents the same protocol. However, now the panel on the top shows a superimposed twitch evoked by TMS, and the bottom panel shows a superimposed twitch evoked by motor point stimulation. There was a main effect of group on the superimposed twitch evoked by TMS, with MS demonstrating an increase in superimposed twitch during the exercise task compared to controls. There were no differences in the superimposed twitch evoked by motor point stimulation between groups. These findings suggest that people with MS may experience suboptimal output of the motor cortex despite no differences in perceived exertion. Thank you.